Hey there, welcome to Pomodoro Joe for Wednesday, October 18th, 2023. Today we're looking at LeetCode problem 2050, Parallel Courses 3. This is a hard problem. All right, you're given an integer n, which indicates that there are n courses. These are like college courses or classes, like school. So you're given an integer n, which indicates that there are n courses labeled from 1 to n. You are also given a 2D integer array, relations, where relations index I is the previous course and next course. It denotes that the previous course must be completed before the next course can start. It's the prerequisite. Okay, so basically we're given a list of courses. Some courses have prerequisites, meaning you have to take another course before you can take this course. Furthermore, you are given a zero-indexed integer array time, where time index I denotes how many months it takes to complete the I plus 1th course. Okay, so that's weird, but that's saying if time is index 0, that's the number of months it takes to complete the 0 plus 1, or the 1th course, or course number 1. So this is a little weird. Basically, we're given n courses labeled from 1 to n. But our time is a zero-indexed array. So 0 maps to course 1, 1 maps to course 2. All right, so we'll just have to keep that in mind when we use the time. All right, you must find the minimum number of months needed to complete all the courses following these rules. You may start taking courses at any time if the prerequisites are met. Okay, so we meet our prerequisites, then we can start taking the course. And number 2, any number of courses can be taken at the same time, so we can take a bunch of courses in parallel. Good to know. Return the minimum number of months needed to complete all the courses. Note, the test case is generated such that it is possible to complete every course, i.e. the graph is directed acyclic graph. Okay, we can be assured that we're not going to end up in cycles. All right, we have an example. Let's take a look. So course 1, course 2, and course 3. So in our input, we have 3 courses. And our relations are, course 3 depends on course 1, so course 3 has a prerequisite of 1, and course 3 also has a prerequisite of 2. Now the time it takes, so course 1 takes 3 months, course 2 takes 2 months, and course 3 takes 5 months. So we can look at these and see that course 1 and course 2 can be done in parallel, so we basically choose which one will be the maximum. So it's going to take course 1 3 months, so we can do course 2 at the same time, and after 3 months we've completed both course 1 and course 2. And then we have to do course 3, which takes 5 months. So it looks like that's going to be 5 plus 3 is 8, and that is right. All right, example 2. A little bit more complicated. So we have course 1, 2, 3, 4, and 5. Now, okay, so we have 5 courses, and then relations. So 5 has a prerequisite of 1, 2, 3. And 3, let's see, 4 has a prerequisite of 3, and 5 also has a prerequisite of 4. All right, so 5 depends on 1, 2, 3, and 4, but 4 also depends on 3. All right, so course 1, 2, and 3 can all be done in 3 months because we can do them in parallel. Course 4, however, can't be started until course 3 is done. So course 4 will take 4 months, but we have to wait at least 3 months for course 3 to finish. So that will be 7 months. And then 5 will take 5 months to complete. So that's 3 plus 4 plus 5. That's going to be 12. That's right. Okay, so let's put 25 minutes on the Pomodoro timer and we will get started. This one actually doesn't seem that bad. I think we can do this pretty quickly. All right, so first thing I want to do is convert my list of relations here into something a little bit more usable. So let's turn this thing into a graph. All right, so make a note here. We're going to build a graph. And let's see, I'm going to make the key is equal to the course, and the value, let's see, this will be a dictionary. So it'll be a default dictionary where the key is a course, and the value will be, I guess, the prerequisites that are needed for this course. Okay, and that's going to be the prereqs. Okay, so let's see, we'll have a graph and we'll make it a default dictionary. And that'll be a default dictionary of lists because we'll have a list of all of our prereqs for this course. All right, so then for every course, well, actually, let's see. It looks like we've got our prereq and then our course. So I can break this out into prereq. So for the prereq and the course in our relations. So this is a little bit advanced Python, slightly advanced, not really advanced, but a little advanced. So I'm actually breaking out our list into its two elements as we iterate through it. You don't have to do it this way, but it's a little bit cleaner, a little bit faster. So for every prerequisite and course in our relations, we'll set the graph for this course. We'll just add or append. Oh, I guess I can make these sets because they're not really dependent on their order. That might be a little bit faster. Well, we'll stick with list for now. That'll be an optimization we can do later if we want. So we'll append the prereq. All right, so this builds up our list or our graph of courses. So for every course, we know its prerequisites. That's going to help us down the line. All right, so I think my plan, to take a step back, we'll go through our graph, but I think we only really want to start at these root nodes. So basically we have certain courses that will have these prerequisites, but they are not going to be prerequisites themselves for any other course. So this course 3, for example, is like the last course you'll take because you don't have to take any courses after this. It has some dependencies that you have to take first, but once you take this course, you're done. So this is kind of our root course. We might have more than one. So I think I want to keep track of my root courses. Then for every root course, I'll just look back at its immediate prerequisites because they can all be done in parallel. And I'll say, well, what's the longest time it's going to take for each one of these immediate prerequisites? Because they can be done in parallel, the longest one is basically the one that determines how long it's going to take. All the other ones can be done in that same time or less. And then those we'll have to recurse on. So for example, on this one, we'll look at 5. We'll just look at 1, 2, 3, and 4. Which one of these will take the longest? Well, 4 is going to take the longest because it has other dependencies. So we'll have to do a recursive call on 4, and then it just looks at all its dependencies. It's just got 3. And then 3 will have to look at its dependencies. There aren't any. And then we can pop back up, and that's our answer. Hopefully that makes sense. Okay, so I've got my graph, but I kind of want to know which courses are these root courses. So let's actually have a set here of root courses. I'll just make that a set. And in fact, what I think I'll do is I'll make it a set that will initialize with all n courses. And then as we go through here, when we find courses that are prerequisites, then we can remove them from the root course because that means it's not a root course. It is a prerequisite for some other course. So let's actually initialize this with range n, n plus 1, because range is non-inclusive and we need to go all the way to n. All right, so the root courses, set of range n plus 1, minus 0 actually. Yeah, because there is no course 0. So I guess we can go from 1 to n plus 1. All right. And then in here, as we're going through, so this is a prerequisite. If this prerequisite is in our root courses, we'll remove it. Because we know that it's not a root course, it's a prerequisite course. All right, so now we have our list of root courses, and we can go through each of our root courses, and we can basically do a recursive call on all of its prerequisites to find out which one is the longest. So let's see. Let's build out the loop part first, and then we'll go back and build out our recursive function. All right, so let's see. I'll need some result. And let's see, that'll equal 0 to start. And for every course in our root courses, let's find the time it's going to take to do this course. So time for course, or I'll just call it. I can't call it time. I already got something called time up here. All right. So time for course. That's going to equal, we'll have this function. Now I'm just going to declare it here. We'll just pretend that we have this function. So time for course, we'll pass in this course. And then if this time for course is greater than our current result, then that's got to be our result. So actually, I'll just do it this way. Result will equal time for course if time for course is greater than our current result, else we'll just keep our current result. And then at the end, we'll just return our result. Okay, so this is our sort of engine loop here. We have our result, we're going to start it at 0. Then we're going to go through all of our courses in our root courses, that's these n courses, and we're going to call this magical function that we don't have yet called time for course. And we'll check to see how much time it's going to take to complete that course. All right, now the one course that takes the longest amount of time will be our result. That's the best we can do. So for every course, we call our function to find out how much time it's going to take, we compare that to our current result, and then we just choose the maximum so far, and we return our result at the end. So now we have to complete this by creating this time for course function. All right, so this is going to be a recursive function. So time for course, so it's just going to take some course, C. All right, now what's our base case? Our base case is that this is a leaf course, or this course has no prerequisites. We just take the course. So let's see if our graph at this course is empty. So I can say if not graph at this course. So if we look up this course in our graph and we have an empty list, so if not graph at this course, that means there are no prerequisites. We can just return the amount of time it's going to take to complete this course, and that's in this time right here. So we can just return time for this course. No, time for this course -1, because again, this is 0 indexed and the courses are 1 indexed. So course 1 equates to index 0. So it's going to be course -1. Okay, so that's our base case. If we don't have any prerequisites, this is how much time it's going to take, the amount of time it just takes to take that course. Now, if we do have prerequisites, then we basically have to go through all of our prerequisites and do a recursive call, finding out how much time it's going to take that prerequisite. And we only have to care about the longest prerequisites because all the other ones can be done in parallel. So for this, we'll have like a max prerequisite. And let's see, we'll start it out at 0 because we don't really know how long it's going to take. And then so for every prereq in our graph for this course, so that's every prerequisite for this course, we'll just find out how much time it's going to take. So that's going to be prereq time, and that's a recursive call to this function. It's like, oh, if only we had a function that could tell us how much time this course is going to take. Well, we do. It's called time for course. It happens to be this same function. So the time it's going to take this prereq will be time for course for this prereq. And then we just update our max prereq based on which one is the maximum. So let's see here. Our max prereq, let's do it simply. It's going to be the max, or so I'm just doing this simply by calling the max function on either the current value or the value for this course. All right, so we're going through all of our prerequisites. We're going to find the maximum prerequisite, however long that one takes. Now we have to add in the time that it took to take this course. So the prerequisite time, that all happens before we actually take this course. And now we have to add in the time that it takes to actually complete this course. So we can return this max prereq time plus the time it's going to take this course, which is time at C-1. And I think we are done. So I think this is it. We've broken this down into pieces. First, we'll generate our graph. Along the way, we'll find out our root courses. That's these courses that are not prerequisites for other courses. Then we'll go through all of our root courses, and we'll find out how much time it's going to take to complete that course by calling this function, time for course. It's our magical function. And we keep track of the maximum time. Now, time for course is a recursive function. If this course is a leaf, meaning it has no prerequisites, we just have to take the course so we can return the time it takes to take that course. Otherwise, we have to go through all of our prerequisites, finding out which one is going to take us the longest to complete. However long that takes, we have to add in the time it's going to take to complete this course, and then we can return the total time to complete all of our prerequisites plus the time it takes to complete this course. Whew. All right, let's run this, see how we do. Seems to work. I think before I actually submit this, I am going to add caching because I'm pretty sure this is going to be too slow if I don't. So I'm just going to add cache to my recursive function. And we'll give this a shot. And we pass. All right, and let's see how we do. We do all right. We beat 70% for runtime and not great on memory. Only 8% for memory. So we could do better in memory. It's probably this cache. So we can jump back really quick. I'll try one thing. So I'm using this max function. Oftentimes we can do better with writing our own. So let's jump back here. We'll write our own max. All right. So that might save us a little bit of time. Let's see if it does. Let's see, yeah, a little bit. So we go from a 70% up to an 80%, so that's not too bad. Doesn't save us anything on our memory though. We could also do something in here. Instead of using this cache, we could do our own DP. And in fact, we could probably just keep an array of all of our classes. So array of size n, and we can actually look back at our previous classes and just store our value in that array. That would actually be a good way to do this. I think I'll leave that as an exercise to you. See if you can do this one without using this caching or this graph. Well, you'd still probably need the graph, but the graph could be an array. Anyway, I'll leave that up to you. Give it a shot. Okay, so that is it for this one. Again, this is LeetCode 2050, Parallel Courses 3, and it's a hard problem. So give it a shot. Of hard problems, this is a more reasonable hard problem. You could probably do this without too much trouble. All right. I hope you enjoyed this. I hope you had fun. Hope you learned something. Hope you can go out and write better code.